This is a CCEA GCSE Further Maths Statistics paper. This one's from the summer 2023. So let's take a wee look then at question 1. At a singing contest, 8 competitors were scored on each of 2 songs. The table below shows their scores for each song, first song, second song. Write down in the table above the rank orders for the first and second songs. Well, for the first song, I think 78 is the highest. So we're given that then number 1. 76 is number 2. 75 is number 3. 73 is number 4. 71 is number 5. 6. I think that's 7 there, and that's 8. For the second song, that's 1. 72 is 2. This is 3. I think this one here is 4. Sorry about that. Number 5, if we look here, we have 2 then and 69. So they take up 5 and 6. So we write those in as 5.5. So that's 5 and 6 done, and then that's 7, and then that's 8. So that's my rankings in for each of those. So it was terrible recording there. Calculate Spearman's coefficient of rank correlation. So we need to find the difference then in between these. So the difference is then, take those 2 away, is going to be, well, we can do kind of -2, I suppose. That's going to be 0. That's going to be 0. That's 1.5. That's 0. This take away this is -2.5. This take away this is 3, and this take away this then is 1. And of course, then for d squared, we're going to square each of those. That gives me 4, 0, 0, 2.25. That's going to be 0, 2.5 squared, I think. Then gives me, sorry, wait, apologies, that's 3.5. So 5.5, so 3.5 squared, that gives you 12.25. That's going to be 9, and that's going to be 1. So for Spearman's rank correlation coefficient, we need to add these up, and the sum of the d squareds in. If you add all those up, you can take my word for it, you get 28.5. And then we're going to go to our formula. The formula is given now, so just look it up at the inside front cover. But our formula is R is 1 minus 6 sigma d squared all over n upon n squared minus 1. So if R equals 1 minus 6, the sum of all the d squares, as I said, is 28.5. Check for yourself and just add them up. And we had 8 songs, so it's 8 upon then 8 squared is going to be 64, take away 1 is 63. So you want to put that all into your calculator, do the sum, don't forget the 1 minus, and we get 0.66. Interpret your answer to part 2. That means we have a positive correlation. Close, I think, to a strong positive correlation, but that's what we'll have. Calculate the mean mark for the first song and the mean mark for the second song. Let's see where I go from this. I lost my first page already. Okay. So obviously you just need to add up these here and divide by 8, and add these and divide by 8. So it's sure working then for that. So the first song is going to be 568. Again, add those up, you'll check that that's the case. You get 8 divided by 8, you get 71 for the second song. If you add them all up, you get 560 divided by 8, and then that's going to be 70. So the mean for the first song is 71, and the mean for the second song then of course is 70. The data from the table are plotted in the graph below. Draw your line of best fit on the graph. Well, we know that the line of best fit needs to go through the mean, and that's the point 7170. So my point 7170 is going to be here, and then we need to do our line of best fit then going through there. Now it's tough enough to do this. Hopefully people can see it's a positive correlation. It's going to be going that way. We do not need to go through this point here, not that that's even the origin anyway, and generally you want half above and half below, making sure you go through the mean. So I'm going to go for round about here, and to be honest I've kind of looked at the mark scheme and they've done something similar, and so I think if we see, I can go there round about there maybe, kind of there's my line of best fit. Again, yours might be a bit different looking than mine, but that's okay. So our line of best fit then goes there. Determine the equation of the line of best fit that you have drawn. This is always a wee bit messy. The numbers are normally kind of quite awkward. So first of all, we need to try and get our gradient. So our gradient, and we want to find then kind of 2 points on the line. So I'm going to pick the point we definitely know is the point 70, 7170. That's definitely on the line, so we're going to use that. And I'm just going to pick here, and so that's going to be 60, and then 66, and I'm going to pick 66.4 there as kind of this wee point here. So 60, 66.4. So we're going to go, first of all, the y difference. So 60 take away 66.4. Again, this is actually from the mark scheme. You can accuse me of cheating if you wish. And we have that. You put that in your calculator and you get 0.33. That means it's going to be y equals mx plus c. Y equals 0.33 x plus c. And then we need a point on the line. This, of course, just be careful, you can't write that as the c, because that's not actually the y-axis. The y-axis is way, way, way over here. So we need to kind of then pick this point here. So I'm going to pick a point on the line, and again I know 7170 is on the line, so I exchange my 70 for y, 0.3371 plus c, and then a wee bit of calculation to get the c on its own, and it'll give you 46.57. Again, take my word for it, just put it into your calculator and work it out. So my equation of the line then is y equals 0.33x plus 46.57. Okay, question 2. The speeds of 10 cars and 4 lorries are recorded in a 30-mile-an-hour zone on the road. For all 14 vehicles, the mean speed was 32 and the standard deviation was 4. The speeds of the lorries were 28, 30, 33 and 40. Calculate the mean speed of the cars. So what are we going to have to do? We're going to have to add these up. So lorries, it's going to be 28 plus 30 plus 33 plus 40. If we add those up, I think I'd be able to work that out in my head, wouldn't you? 70, 73 plus 28, I think that comes into 131. Mean speed of them all, so we have mean speed is 32, so that means the total is going to be 32 times by 14. 32 times 14 gives me 448. And then, so to work out the mean speed of the cars, I'm going to go 448, take away 131, and that gives me 317. And that means then the mean of the cars, so all the cars must add up to 317. And of course there are 10 of them, so that's going to give me then 31.7 miles per hour. The standard deviation of the speed of the cars, so let's see what we have here again. Speed standard deviation then of them all then was 4. So let's see what we have to work out. So for all vehicles, then our standard deviation is the square root of sigma x squared over 14, and we know our mean is kind of 32 squared. So we know the standard deviation is 4, so I'm going to square both sides here. So 4 squared equals sigma x squared over 14 take away 32 squared, and we need the sum of all the x squareds is effectively what we're getting here. So I'm going to do 4 squared, I'm going to add the 32 squared, and I'm going to times everything by 14. Again, put that into your calculator. You're trying to get this bit here on its own, and it gives you 14560. That means then for the cars, the sigma x squared, that's for them all, and so we need to then square those 4 values that we have. So it's going to be 14560, take away these ones squared, so it's 28 squared plus 30 squared plus 33 squared plus 40 squared. And if you do that, you get 10187. So my sigma x squared for the cars is 10187. Therefore, standard deviation for the cars is going to be the square root of 10187, all over many cars have we 10, and then our mean for the cars, as you know, was 31.7. We worked that out in part 1. Put that all in your calculator and you get 3.72. So that's my standard deviation then for the cars. Okay, question 3. Residents in a hotel could book a table for breakfast, lunch or evening meal. Of the 80 residents on a given day, 12 booked a table for all 3 meals. So let's start to fill this in here. So I need to move up and down again, but we have the 12 here. 46, you see that 46 booked the table for breakfast and evening meal. So breakfast and evening meal is going to be this bit here. So 46 take away the 12, so that must then be 34. 25 for breakfast and lunch. So 25 for breakfast and lunch, making that up then to 25, that would have to be 13. X booked the table for lunch and evening meal. So lunch and evening meal only. See the way they have the only there, sorry, rather than kind of the thing of all 3. And then 65 booked the table for breakfast. So that's 34, that's 12, that's 13. You add those all up, I think it comes to 59. Which means then that must be 6. 34 booked the table for lunch. So this plus this plus this plus this is 34. So taking away then the 25, you get 9. So if you think about it, this is going to have to be 9 minus x. That's a wee tough one to get your head around. Hopefully that makes sense if you have a wee think about it, because we know all of those. The 34, and then this one is 57, book the table for evening meal. So 34 plus the 12 gives me then 46, 57, so that means there's been 11. Take away x. 2 did not book a table for any meal, and we have that. Hence, calculate the value of x. A couple of different ways of going about this, but we know everything here adds up to 80. So this plus 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 this must give us 80. So 34 and 6 is 40. 52, 65, so 67 plus these 3 must then give me 80. So I'm going to write that. 67 plus x plus 11 minus x plus 9 minus x gives me 80. So that means 67, that gives me then 87, that cancels with that, minus x is 80, so that means x must be 7. So my x then is going to be 7. What is the probability that a resident selected at random booked a table for exactly 2 meals? So if my x is 7, then that has to be 7, that has to be 9 take away 7, which is 2. That then has to be 4. So exactly 2 meals, it's out of the 80, and we have this one and this one and this one, and I think then not to 12, so 34 and 13 and 7, so I think then that's going to be 54, so 54 out of 80. Probability of exactly 2 is 54 out of 80. As we know then, that's going to cancel down then to us for 27 over 40. A resident selected at random did not book a table for breakfast, what is the probability that this resident booked a table for lunch? So we're forgetting about everybody who did breakfast. So we're forgetting about these people, and just what's the probability out of these people that they booked the table for lunch. So out of these people we have 7 and 2 and 2 and 4. So that's going to be 15. So out of these people, 9 of them booked the table for lunch. So out of the 15, 9 booked the table for lunch. So you couldn't see that 2 there. So let's say it again. This plus this plus this plus this are the only people we're dealing with, because we're done dealing with the breakfast people. So out of the 15, how many booked lunch? It's going to be 9. So my answer is 9/15. Now you can go back and use a conditional probability formula there, and that will work for you. But that's kind of what we have. So it's going to be 9 out of 15. And that's the probability of lunch, but not breakfast, effectively. 9 out of the 15, and that cancels down then to 3/5, or 0.6. I'll be done with either answer for that. Question 4 then is our binomial one, so complete Pascal's triangle in the grid below. So we're always flanked here with 1s, and then remember the way Pascal's triangle, you add the 2 above, so 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 and 3 is 6, 3 and 1 is 4, 1 and 4 is 5, 4 and 6 is 10, 6 and 4 is 10, and 4 and 1 is 5. Hence write down the expansion of p plus q to the power of 5. So we start off with p to the power 5, and it's a 1 p to the power 5, plus 5, drop the power of p, p to the power 4, introduce the power of q, q to the power 1, that's q to the power 0 by the way, plus 10 p cubed q squared, plus 10, again the p's are dropping in powers and the q's are increasing in powers, so it's p squared q cubed, and hopefully you can kind of see the symmetry of this as well, plus 5 p q to the power 4 plus q to the power of 5. So a biased die is such that the probability of scoring a 6 with each throw is 0.2. The dice is thrown 5 times, the scores are recorded. Find the probability exactly, score a 6 on exactly 2 throws. So we're going to take p to be 0.2 and q to be 0.8. As we know, we're taking n to be 5 here. That's the way the question's been set up. And so we need, where p is 2, so we need this bit here, 10p squared q cubed. So the probability is equal to 10p squared q cubed, and that's equal to 10 upon 0.2 squared upon 0.8 cubed. Put that in your calculator and you get 0.2048. Find the probability that the score is a 6 on at least 2 of the throws. So we have a couple of different ways of doing this one. So it can be 2 or 3 or 4 or 5. So we can work out these 4 and add them together, but hopefully we realise it's actually wiser to work out these 2 and subtract it then from 1. So the probability we require here is 1 minus 5p q to the 4 plus q to the 5. That's technically correct, but we can put in our numbers in from there. And so it's 1 minus, 5, 0.2, 0.8 to the power 4 plus 0.8 to the power 5. Again, hopefully you find this easy enough to type into your calculator, whatever way you want to set it up. But 1 minus this, put it all in your calculator and you get 0.26272 is what comes up. So there's only got 2 decimal places here, so we'll go 0.26. Question 5 then, the heights of a large number of sunflower plants were measured. The heights were normally distributed excuse me, with a mean of 42 and a standard deviation of 5. Hopefully this is popping out at you now as what question this is. Normal distribution, so we're going to deal with our normal curves and we're given our mean and our standard deviation. Find the probability that some flower chosen at random measured less than 50 centimetres and give your answer to 4 decimal places. So we need our z value, that's x minus mu over sigma. So in this case we're asked for 50, so it's 50, take away 42 all over 5. These sums aren't that hard. 50 take away 42 is 8, 8 over 5 is 1 3/5, or if you want then 1.6. So we are looking for less than 50, so it's going to be less than 1.6. So we do our wee normal curve here, and this is 0, so our 1.6 is up here, and the area we want then is this bit here. So we go then to our table, and we're looking at a 1.6. So there's 1.6, and it's 1.60, so it's 0.9452. So the probability that it's going to be less than 50 is 0.9452. Part 2, find the probability of sunflower chosen at random measured less than 36. Again, give your answer to 4 decimal places. So we're going to z equals x minus mu all over sigma. 36 take away 42 all over 5. 36 take away 42 is obviously then minus 6. So it's minus 6 over 5 and then minus 1.2. So let's see how that looks. So it's a probability that it's going to be less than 36, and that's the probability of my z value then being less than minus 1.2. So my minus then is going to be to the left hand side, and we're looking, that's minus 1.2 there, and we're finding this area here. Now as you know, our table doesn't give that value, it only gives from here up, so we need to do a wee bit of manipulation. We need to realise that this area here is the same as, that's why I put the equal sign there, this area here, where that's 1.2. So what am I going to do? I'm going to look up 1.2 on my tables. It's going to give me this white area. I then subtract it from 1 to get what we require. So the way of doing it is the same as 1 minus. In this area here, where this is 1.2. So the probability that it's less than 36 is equal to 1 minus the probability of a z value less than 1.2. So that's the same as 1 minus, and let's look it up then, 1.2. 1.2 again, very easy ones to look at here because you need to read across. 1.2, 0.8849. So I do 1 minus that in the calculator and I get 0.1151. Part 3, find the probability that a sunflower chosen at random measured less than 36 given that it measured less than 50. So that's actually bringing together those two bits and pieces. If we kind of have our two pictures here, I wonder can you see them both? Not quite. So it's this one here and this one here. So it's given that it's in this section, what's the probability in this section? So we just need to divide those two numbers. So it's again, it's a conditional probability. Let's see our best way of writing this. So it's a probability that it's less than 36 given that it's less than 50. 0.1151, we just worked that out in the previous part, divided by 0.9452. Again, the 4 decimal places is going to be 0.1218 whenever you divide those two numbers. Finally, question 6 then. Jack received the following marks in each section of his last PE exam. So we have those 5 marks there. calculate the standard deviation of these marks, you must show your working. So the calculator will sort this out for you, but you can't really do it that way. You can, of course, check it on your calculator if you wish. I'm not going to be going through that, but we're just going to work from there. So when we mean, first of all, we need that to work out our standard deviation. So it's 29 plus 23 plus 11 plus 17 plus 20, and then it's obviously then kind of all over 5. They add to 100, so we get a nice even number then of 20. We need to work out the sum of all our x squareds. So we need to square each of these numbers, so it's obviously going to be 29 squared plus 23 squared plus 11 squared plus 17 squared plus 20 squared. Again, quite a quick, easy wee calculator exercise for us there. If you put those in your calculator, you get 2180. And our standard deviation, again, the formula is there in the inside front cover. Take away look if required. The sum of the x squareds, which is 2180, divided by how many there are, which is 5. Take away the mean squared. Put that into your calculator and you get a 6. Jack needs to scale his marks so that the mean mark is 45 and the standard deviation is doubled. He does this by multiplying each score by a constant m and then adding a constant n. Calculate the values of m and n. So what does he want to do? He needs to say, so the mean mark is 45 and the standard deviation is doubled. So to double the standard deviation, we need to double the marks. So it says we multiply each score by a constant m, so that means my m then is going to be 2. When the marks are doubled, obviously the mean was 20, so with the marks doubled, the mean is now 40. So what do we have to add to make the mean 45? Well then, we need then to add 5 and nothing else to it then than that. So my m is 2 and my n is 5. So I have 2 here and I have 5 here, and that's us done.